Next up, we have Christina McGahan, a postdoctoral fellow at Mount Holyoke College and part of the Center for Integrated Quantum Materials, which is working to build new atomic scale materials with extraordinary properties. Take it away, Christina.
Imagine that you are driving your car or pedaling your bike down the road. The sun is shining and it's a warm day. But up ahead, you see it. A big pothole. You have to slow down so you don't damage your car or hurt yourself on your bike. In my research, I fix potholes, just not the ones in the road. I fix electrical potholes. This electrical equivalent of potholes in materials makes electricity move slowly through the materials at certain spots, which makes electrical devices made of these materials, like phones and computers, not work well. We can see potholes in the road, but we can't see these electrical potholes with our eyes or with a light microscope because they are 10 times smaller than the thickness of a strand of your hair, or even smaller than that. So we need something that can sense smaller objects. But how can we figure out information about an object, like this mask, if we can't see it with our eyes? We can touch it with our finger to figure out how rough it is or how it's shaped. What I use in my work, and that's me, is an atomic force microscope, which has a tiny finger 1,000 times smaller than the thickness of a strand of your hair, or 100 times smaller than the potholes. This tiny finger can measure things like roughness and shape, but also things that our finger can't measure, like how electricity is moving through a material. So I use this tiny finger to find electrical potholes that make electricity move slowly in plastics and in two-dimensional materials. These are like sheets that are a single atom thick, so super thin compared to this paper. Once I find these electrical potholes, I can figure out why they're forming, and from there, how to get rid of them. In my work, I bake the plastic by heating it up in an oven in order to cover the material with a layer that fills in the electrical potholes and also doesn't let new ones form. Now, the material is free of electrical potholes and electricity can move faster through the material. With my improved materials, scientists can make better devices, like phones and computers, and even better solar cells that take more light from the sun and turn it into electricity. Thank you.